Welcome to NP Hacker! In this video we are going to build a homemade USB emergency charger. Because I happen to have a pile of old lithium-ion batteries from some old mobile phones I've got. So I'm going to pile them up in a big stack and then I'm going to build this homemade do-it-yourself USB charger or outfit.
Not party yet. Not party yet.
Okay, so first thing we need to choose is parts, and for converting the 3 or 4 volt on the battery to 5 volt to the USB, I will use the LiPower boost converter from Sparkfun. It takes whatever voltage and outputs 5 volts for the USB. I'm also going to charge the battery, and for that I will use LiPo charger for Sparkfun. And first thing we're gonna do is to build the battery pack. We are going to put the batteries, connect them in parallel. That means plus to plus, minus to minus, like this. And I use this for support to make soldering easier. I soldered a wire to the plus terminal and cut away the insulation, and now I'm going to solder it to the other battery's plus side. You do that by putting some solder on the tip and press it against the surface so it heats up, and then you add some more solder. And then you get a nice clean solder joint. Because the two batteries can have a little different voltage, then it's important to equalize that voltage difference. You do that by putting a resistor, in this case 55 ohms, across the terminals for a minute. And then it's ready. I have connected the positive and the negative, and then it's important to put some electrical tape to insulate it from short-circuiting. So I ordered the parts from Sparkfun, as I said, a LiPower from Sparkfun, which takes the battery to the right connector and then it outputs 5 volts to the left, so that I connect to the USB. Then I also have the LiPo charger basic, also from Sparkfun, that has a micro USB connector for charging, so you can put any charger there or connect to the computer, and then to the left you connect the battery with this GST cable. So it's time to prepare what I will use as the USB port. I am going to use an extender cable here, and I clipped off the male connector, leaving it with this end. So I put away all the shielding, and I'm left with these 4 wires. So the white and the green I'm going to put away, because those carry data, and remaining I will have the black and the red for carrying power. Of course, black for ground, red for plus 5 volts. And strip off the insulation from those cables. And then I'm going to do some preparations for the LiPower. I will put this ceramic capacitor to the 5 volts output. That's just to stabilize the output, so I don't get any voltage spikes that could possibly kill my device or phone. It's probably not necessary, but I'm going to do that anyway, just to be cautious. I have a little bit too big solder tip for this, but it goes okay. Then to the battery terminals here, to the solder terminals, I will connect this wire. That's going to go to connect to the charger, so I can charge it easily. And as well though. And inspecting the solder joints, they look pretty good, I would say. So onto this cable I just soldered to the LiPower, I can then connect the charger, so the charger will get a direct connection to the battery that way. Okay, and now we only have to connect the USB connector. I will use the legs from the capacitor for that, as those are directly connected to the 5 volts out. The red wire, that is plus. The red wire on the USB, and on the LiPower you can read, it reads VCC, that's positive voltage. And on the left side of the LiPower it reads GND, or that means ground. So there you connect the black wire then. And here we have it. And of course this is where I connect the charger through these cables, and battery goes out to the right. So we are almost finished. Now I'm just going to plug in the battery connector to the LiPower, and the project should be good to go actually. But first, yes, it's important to put insulation to the wires, and also put some strain relief to the battery, and insulate this as well, and put it in a nice package with tape. And as I said, the device is fully functional. We have the battery powering the device to the left, and the LiPower itself in the middle that converts the battery's power to a suitable voltage. I will not try it with my expensive phone, so I'm going to use this cheaper GPS receiver to test it out. And I plug in the mini USB cable to the USB port, and the mini USB cable to the device itself. Yeah, we have a charging indicator light up. It's working. So, with the device itself ready, I'm going to build a case. I'm going to use these cups branded with my local Polytechnic school logo. And I cut away some extra parts from the yellow one, and cut out a hole for the USB charger, so the USB charging port sticks out. And inside the blue cup we put the project itself with the battery, quite big, 5 batteries connected in parallel. And yeah, here is the cable that will connect to the charger up in top, so that gets connected as well. And here is the finished product. You see? Here is the USB port, then here you can plug in any micro USB cable or whatever that your device needs to charge. And plug the micro USB inside your phone, for example, and yes, sure enough, you will have a charging indicator. It charges. Yeah, nice. And for charging the charger itself, it's not that hard. You just plug in a micro USB charger. It can be a charger or just connected to your computer. Plug it in, and it will light up a little LED that is connected on board to the charger, and that will light up.
So here you have it. A battery-powered, do-it-yourself USB emergency charger. Before we end this video, I'm going to show you different variants of this device. As you saw earlier, I only connected the red and black cable to the USB cable, those carrying power, and left the other 2 data pins unconnected. That tells the phone it can only draw an amount of 500 milliamperes from this device. And 500 milliamps is quite ideal, because the LiPower is at most efficient at that current. So when you draw 500 milliamps, you will get an efficiency about 90%. If you would draw any higher current, the efficiency would be lower. However, according to the USB battery charging specifications, you could short-circuit the 2 data wires or solder them together. That would make the phone able to draw a current of 2 amps or 2000 milliamps. However, the LiPower would probably not be able to give out such an extensive amount of current. So that's why I didn't connect those two wires together. This device won't work with Apple devices either, like iPhone or iPads. That's because Apple uses their own charging protocol. So, in order to make this device able to charge an Apple device, you would have to put some resistors between those two data pins to make a voltage divider and tell the iPhone that this charger is an iPhone charger. The reason why I didn't do that is because, one, I didn't want to waste my resistors because I don't have any iPhones. But the second reason is because I wanted this charger to comply with the USB battery charging specifications. That means that by following the USB battery charging specifications, I can tell the phone not to draw any more than 500 milliamps. Because if I made this an Apple charger, the phone could maybe draw anything it would like. So that's the second reason this is not Apple compliant. But if you use an iPhone, you could Google that up on the internet to find out which resistors you should use and how to connect them in order for this device to be able to charge an iPhone or iPad. I hope you enjoyed this project. See you later maybe. Have a great day.